All right, page 2. I love this page. This is a great one because you really get to see how dilation works based off a graph. So I'm a big fan of this page. This is going to be a good one. So what we're going to do, guys, is we're going to graph the image of a polygon with the vertices after a dilation centered at the origin with the given scale factor. So our scale factor is this right here. So for example, on number 1, our scale factor is 2. But first, before we apply that, let's go ahead and graph our original points. I'm going to do these original points, I'm going to do these in red. So 2, 4, 4, 4, and 3, 2. And so in dashed lines, here's our original triangle, the OG. This is J, K, and for some reason P. Okay? Now, for our new points, to find those, we're going to use our scale factor, so we're going to multiply by 2. So we're going to get our new J, our new K, and our new P. Let's see what we end up getting, guys. So 2, 4, you multiply 2 to both those, you get 4 8s. That becomes 8 8s, and 2 times 3 is 6. 2 times 2 is 4. So our new points are 4, 8. There's our new J, J dash, K, sounds like a rapper, 8, 8, K dash, and then P, 6, 4, P dash. And so here is our dilated triangle. We doubled the size of this thing, and that's what we got. You can kind of see, too, that got projected from the origin, right? We started here, and then it got projected out away from the origin as we expanded. You're going to see that kind of continue, especially at the bottom of the page. So number 2, I'm going to let you guys try number 2. Ooh, looks like we're going to be multiplying by 2/3. You know what that means? That means this is going to be a reduction. So remember, we got to find out what A, B, C, D, and E is going to be. Looks like we're going to have a pentagon if we're going to have 5 points, but I'll let you guys see what you get here. Go ahead and try number 2. You can pause the video. So we've got our original pentagon right here. I've got it in red. There's A to B to C down to D and then over to E. Well, check it out. We know this is going to be a reduction by 2/3. So when we multiply all these, they all change except for, our new A. 0 and 0 multiplied by 2/3 is still 0, 0. That point is not changing. That's our A dilated. But here's our B dilated. We see that's kind of come closer to the origin. Here's our C dilated, closer to the origin. Here's D dilated, closer to the origin, and E. So we can see that we've definitely shrunk down this pentagon. Okay, the last thing down here before we go back and do a little bit of review. So these look a little complicated, don't they? We're going to determine whether the dilation from K, our original, to K with the apostrophe, our dilation, is an enlargement or reduction. And then we're going to find X. So 2 things. So remember, K is the original. So look at number 1. Here's K. It belongs to this right here. There's K apostrophe. It looks like we took this shape and shrunk it down to that. We got it closer to our original, or closer to the origin there. As it went towards that, it got smaller. So that's definitely going to be a reduction. Now to find X, we see that from the dilation to the origin here is 2. Between our reduction and the original is X. x, and then from the origin all the way to our original is 5. Wait a minute, if we want to solve this for x, let's say a seg add post, because we know part plus part should equal the whole. So 2 plus x should equal the whole piece, or the whole side, 5. Subtract 2, we know x is going to be 3. So it's a reduction from that to that, and x is 3. Remember, here's our origin. Now it looks like we've got our originals right here, this tiny pentagon, and we're going to this. So I'm going to let you guys try number 2. You can go ahead and pause the video. We see we're going from this tiny pentagon up to this one. And so that's definitely an enlargement. And then part plus part equals whole. 10 plus x should equal the whole stretch, 15. So when you subtract 10 over, we know x is going to be 5. And so we've got both these done, guys. Little throwback to SegAdd post from chapter 1. So last thing for today, let's flip over to page 3. And I just want to give you guys a quick reminder. This is actually going to be one of your free responses. This is going to be part 3 of your test. Our test is going to be around 3 parts. This is going to be the final part of your test right here. A problem kind of like this with probability. So be very careful here, guys. So for an upcoming concert, each customer may purchase up to 4 child tickets and 3 adult tickets. We're going to let T be the number of child tickets purchased by a single customer. So we're really focusing on the child tickets. We don't really care as much about the adult tickets here. The probability distribution of the number of child tickets purchased by a customer is given below. Okay. So T is going to be, we know it's going to be the number of tickets. And then down here, guys, is the probability. The probability that we did get this many tickets. So the probability of us getting 0 tickets, for example, is, well, that's 10%, 0.1. The probability of us getting 1 ticket, 35%. Ooh, now wait a minute. We know that's 20%. That's 10%. How are we going to find out the probability that this person got 2 tickets? Well, shouldn't all this, the probability, what does it always add up to be? That plus that plus that plus that plus that. Shouldn't that add up to be 1 or 100%? Yeah, so if you want to find out pretty quickly what 2 is going to be, find out 0.1 plus 0.35 plus 0.2 plus 0.1. That adds up to be, this all adds up to be 0.75 plus this needs to add up to be 1. So subtract 0.75 over. We know that this has got to be 0.25. Yep. Okay, so what's the probability that a customer bought at least 2 tickets? Now remember, throwback to Algebra 1. At least 2 means 2 or more tickets. 2 or more. Okay? So what are the chances that we got probability of number of tickets being greater than or equal to 2? This is not difficult math, guys. We start with 2, so 0.25. And then we're cool with getting 3 tickets plus 0.2. And then we're cool with getting 4 tickets as long as it's 2 or more. That's plus 0.1. So the probability of a person getting 2 or more tickets would be, well, you guys can do the math, 0.55. We know that's 55%. So got about over half a chance. Okay, I'm going to let you guys try number 2 and try number 3 for me. See if you can try both these. You can go ahead and pause the video. Give it a shot. All right, let's see how you guys did. So part 2, what's the probability that a customer bought more than 2 tickets? Also, that would be 3 or 4 tickets. Okay, so that we know that's going to be 0.2 for 20% for 3 tickets and 10% for 4 tickets. So you add those together, you get 0.3 or 30%. Now, what's the probability that a customer did not purchase 3 or 4 tickets? So in other words, they got 2 tickets or less. So that would be, so not 3 or 4. So we're going 2, 1, or 0. So pretty straightforward there. But also, couldn't we just do 100% minus? Didn't the last time we found out how much it was if they did get 3 or 4 tickets? Yeah, it was 30%. So that they did not get 3 or 4 tickets, 1 minus 0.3. We know that's 0.7 or 70%. This is maybe one that's kind of confusing to some of you guys. So what is the expected mean or expected value? So this is where we're going to combine all elements. And what I mean by that is we are going to add these together. But we're also going to multiply in these the factors of the number of tickets too. So whenever you find this, it involves multiplying and adding. So here's what we're going to do. We're going to say, okay, what are the chances that they got? What are the chances that they got 0 tickets? Well, we multiply that by the probability, 0.1, which really that's just going to become 0, plus what are the chances they got 1 ticket? Well, we know that the chances there are 0.35, plus what are the chances they got 2 tickets? So you see what we're doing here? Number of tickets times the probability, number of tickets times the probability, plus number of tickets times the probability, plus number of tickets times the probability, plus, you guys get the idea. And whenever you type all that into a calculator, we obviously know that's going to go away, plus 0.35, plus that times that, plus that times that, plus that times that. I believe we end up getting 1.85 tickets on average. So what we're saying here, guys, is we're saying, hey, our expected value, if we were running this situation, would be that on average, we're seeing about 1.85 tickets bought on average for children. Remember, this is children's tickets. 1.85 children tickets on average. But check it out, guys. Part 5, suppose that the average number, somebody else calculated the average number of adult tickets is 1.5. Find the, here's the key word, combined average. Find the combined average number of adult and child tickets. Okay, this is easier than it sounds. So we're doing the combined number. So we just found that the number of child tickets on average bought is 1.85. So that's going to be 1.85 for children. And we're going to combine that with, add it with the number of adult tickets on average. And so guys, what's the number of tickets in total being bought on average? Well, 1.85 plus 1.5, that's going to give us 3.35 is the number of tickets being bought on average. That's children and adult combined, which is crazy expensive when you consider tickets are like $8. So great job on that, guys. That's going to be one of your free responses, this right here. So be ready for that. Your homework is going to be this right here, guys. We're going to have these 2 problems. Problem 1. Remember, these are 2 different problems. Here's problem 1. And then here down here is kind of like problem 2. So thank you very much, guys. Hope you have a great weekend. And let's get this done.